NASA has revealed the discovery of the first alien signals emanating from the direction of Proxima B, a startling revelation that may alter our place in the universe. The nearest exoplanet to Earth is Proxima B, which is situated in the habitable zone of its star, Proxima Centauri, just over 4 light-years distant. Around the world, this finding has sparked a surge of interest and excitement. Is this the time when mankind realizes it is not alone in the cosmos? NASA's powerful telescopes, which have been keeping an eye out for evidence of life on distant stars and planets, made the first careful observations that led to this historic discovery. Because Proxima B is close to our own solar system and possesses Earth-like features, it has long been a top contender in the hunt for extraterrestrial civilization. A potential turning moment in human history has been marked by the unique signal that astronomers have never seen before. This kind of revelation has significant ramifications. In the first place, it supports the long-held scientific theory that life may exist on other worlds with similar conditions to Earth. It also begs the question of what kind of civilizations might live there, which is arguably more interesting. Would they be simple microbes or highly developed entities with the potential to communicate across interstellar space? This signal from Proxima B includes a systematic repeat that points to an intelligent origin rather than being just random noise or a spontaneous cosmic phenomena. It is now up to NASA scientists and worldwide teams to interpret this communication, attempting to comprehend its meaning and the motivations behind it. Theories and conjectures regarding the potential substance of this message are rife in the scientific community worldwide. Is it a salutation, a warning, or something else entirely? Beyond the scientific community, discussions about this discovery have been sparked on social media, in government offices, and at dinner tables all over the world. With a fresh sense of awe, people are gazing up at the sky and wondering if there are beings on a far-off planet doing the same. To what extent does their reality resemble or differ from ours? What kind of culture and technology would exist in their society? These options appear to be as endless as the cosmos. Furthermore, this discovery raises several existential and ethical issues. If the signals are indeed from sentient beings trying to communicate, how should humans react? What is the best course of action for intergalactic diplomacy? Most significantly, how would such a finding alter the way we see religion, life, and our basic humanity? There is a noticeable sense of caution mixed with the mounting exhilaration. To make sure the signal is not a false positive or a misinterpretation, scientists at NASA and other satellite organizations are hard working to validate these discoveries. The next steps must be taken carefully and responsibly since we are about to make what may be the most important discovery in human history. The world eagerly awaits a more thorough examination. In addition to advancing our scientific endeavors into a new age, the discovery of extraterrestrial signals from Proxima B brings us together with a shared sense of wonder and optimism. One of the oldest and most important issues we may finally be able to answer is whether or not we are the only being in the universe. A radial signal was discovered in April 2019 emanating from space, more precisely from the Proxima Centauri region, which is 4.37 light-years from Earth. At 3 times the distance of the next brightest star in our sky, this may seem like a long way, but it is the nearest star to the Sun. Alpha Centauri A and B and Alpha Centauri C, sometimes referred to as Proxima Centauri, are binary pairs that make up the triple star system from whence the signal originates. The 2 star partners, Alpha Centauri A and B, are fairly close to one another and resemble the Sun in many ways. Alpha Centauri is 1.5 times brighter than the Sun and glows yellow, whereas Alpha Centauri B is half as bright but has an orange tint. Our Sun lies precisely in the middle of the size range of Alpha Centauri A and B, which are somewhat bigger and smaller than each other, respectively. This signal is known as Breakthrough Listen Candidate 1 or BLC-1 by the groundbreaking Breakthrough Listen project, which is devoted to looking for extraterrestrial communication in the universe. With funding of about $100 million, the project has utilized thousands of hours of observation with cutting-edge telescopes worldwide. The Parkes Radio Telescope in New South Wales, Australia, which was monitoring the area around Proxima Centauri, the star that is nearest to our Sun, picked up the signal. Among the enormous amounts of data gathered over thousands of hours, this signal nearly went undetected, but scientists were able to find it like a needle in a haystack. The signal needs to possess two distinct qualities in order to be deemed significant. Since such radio waves are not produced by natural forces in space, it must first be restricted to a narrow frequency range. Second, the frequency needs to change in accordance with the exoplanet's relative motion in relation to Earth. The telescope in Australia recorded almost 4 million unique signals, which scientists had to examine. One signal stood out among the 5,000 distinct signals they discovered after a thorough process of filtering and removing extraneous frequencies. This signal was inexplicable after cross-checking with modern radio transmitters on Earth. Only after the telescope was aimed at Proxima Centauri and examined for 30 hours did this distinct signal, which has a narrowband technological signature, emerge. Following further examination, it was identified as Proxima B, an exoplanet that scientists had found in 2016 by employing the radial velocity method. This technique finds changes in a star's location brought on by the gravitational attraction of planets in orbit. With a radius 1.1 times Earth's and a mass 1.3 times Earth's, Proxima B is a rocky world with an equivalent density that appears to be very similar to Earth upon closer inspection. There are notable distinctions, though. The first is where each planet is located within its solar system. Mercury is 0.39 astronomical units away from the Sun, but Proxima B is barely 0.05 astronomical units away from its parent star. Proxima B would be a very hot planet due to its close proximity, but because Proxima Centauri is a faint red dwarf, it only receives 60% of Earth's radiation from the Sun, which puts it in the habitable zone where life may exist. Our universe has a vast number of undiscovered planets. With the latest addition of 65 additional planets, our total number of exoplanets has now reached 5,000, and we have found an astounding 4,935 so far. This year's March 21st marked a significant milestone in planetary exploration with the addition of this most recent collection of 65 exoplanets to NASA's Exoplanet Archive. With 100 times the power of its predecessor, the James Webb Space Telescope, JWST, is the most sophisticated telescope ever constructed. We shall be able to discover the mysteries of the vast cosmos with its assistance. From tiny rocky worlds to gas giants bigger than Jupiter, as well as highly hot and livable planets, we have found a vast array of planets in the past. K2-18b and Kepler-1649c are two planets that stand out among these finds. With traits that are strikingly comparable to Earth's and the ability to support life, the latter planet, Kepler-1649c, is among the most habitable planets found to date. We have found 55 planets that resemble Earth so far, but we haven't had time to thoroughly investigate them all. Who knows what more we can accomplish in the future with the speed at which our technology is developing, particularly because of the James Webb Telescope. Finding a planet that could sustain life would be incredible, wouldn't it? Finding and studying alien worlds outside of our solar system, with an emphasis on their formation and the potential for water and biological life, is one of the primary objectives of the James Webb Space Telescope's first year of science missions. We can connect studies of adult exoplanets to their birth conditions in our own solar system to its origins thanks to Webb's work on star and planet formation. Because infrared light penetrates dust well, can identify the thermal signatures of young stars and planets, and can disclose the presence of essential chemical components like water and organic molecules, Webb's infrared capabilities are perfect for shedding light on the formation of stars and planets. It is particularly crucial to observe newborn stars that are concealed within their natal clouds since mid-infrared light can penetrate clouds that are 20 times denser than visible light. Because they enable us to witness and record the early phases of star formation, when gas and dust are still constricting to give birth to nascent stars, these infrared capabilities are essential. However, the birth clouds of stars are far more than that. Giant planets and young stars both start off as enormous, bloated structures that progressively shrink over time. The Webb telescope will be great for discovering new stars and planets and assisting in the understanding of the physics of their formation, since huge planets cool as newborn stars age and newborn stars get hotter. Both of these planets release more light in the infrared spectrum than at visible wavelengths. Moreover, the MIRI device will look for hot molecular gas close to many young stars, which may be a sign that rocky planets that could support life are forming. It should come as no surprise that a large portion of the early research work on the Webb Space Telescope will concentrate on understanding how planetary systems produce compounds that could be essential to the origin of life.